Alright, so we are going to continue our study of isotopes. So if we remember, isotopes are when you have the same element so in other words, same number of protons but different numbers of neutrons. And two examples of that were carbon-12 and carbon-14. So if we remember carbon-12, 6 protons and 6 neutrons. Carbon-14, 6 protons and 8 neutrons. So carbon-14, carbon-12, they behave chemically. They behave exactly the same. It's that carbon-14 is just a tiny bit heavier because it has those extra 2 neutrons in the nucleus. So when we start talking about isotopes, just to kind of clarify some terms. So one term that we've used, and like when you look at a periodic table, you'll see atomic mass. And what we've said is, so like using carbon as an example, that this, on the periodic table, it says that this number in the top left corner is the atomic mass. And we've also called that number the molecular mass as well. But and the periodic table doesn't explicitly say it, but really what this number is in truth, it is the average atomic mass. And so that kind of lends the question of the average of what? And so it's the average of essentially everything that's found in nature. So for carbon, because it's 12.0111, that's really close to 12. So what that tells us is that in nature, almost all the carbon that we find in nature is going to be carbon-12. We'll find a tiny bit of carbon-13 and a little bit of carbon-14. But it's almost all going to be 12. So how do we calculate this? Really, it's a matter of, essentially, it's just averaging. So, for example, and these aren't real distributions, I'm just going to make it up. But if in nature you were to have, say, carbon-12 be found in, say, 80% of the time, carbon-13 found 5% of the time, and carbon-14 the remaining 15%. So what would that average B. So what we do is we use the mass numbers. So the mass number is so when we talk about mass number, all that is protons plus neutrons. So for carbon 12, 6 protons, 6 neutrons, mass number of 12. Carbon 13, 6 neutrons, 6 protons, 7 neutrons, mass number of 13. And so the mass number is also, when we're talking isotopes, it's this number here, this number here, this number here, this number here, and that number there. So those are the mass numbers, protons and neutrons. So to calculate this overall average, we use this percentage and the mass numbers. And the way we do that is we first convert the percentage to a decimal. So 80 is, so I'll write it this way, average atomic mass is equal to 0.80 times mass number, which is 12, plus 0.05 times the mass number there, which is 13, plus 0.15 times that mass number there, which is 14. So we go ahead and punch that into the calculator, or if we'll just do it kind of step by step. So first, 0.8 times 12 gives us 9.6. 0.05 times 13 gives us 0.65, and then 0.15 times 14 gives us 2.1. And so we add that all together, and we get 12.35. So for these numbers, 80%, 12, 5%, 13, 15%, 14, we end up with a number that's a little bit over 12, still much closer to 12, which makes sense since 80% of it is there.